morning, and let's get started. Our last topic. We're going to be doing this topic for today and tomorrow. And our last topic is called antiderivatives. So I'm just going to read this out to you, and then we'll get jumped right in and do some examples. The process of finding the antiderivative of a function y equals f of x is to go looking for another function called capital F of x. And this function, capital F of x, has the property that its derivative is the original function. So think of it like this. If I tell you what the derivative of a function is, can you work backwards and tell me what the original function was? So the antiderivative is kind of like that. You're going to try and work backwards. You're going to say, okay, what function would you need to start with to get this thing as your antiderivative? So here is some functions, and here is what the antiderivative looks like. So for instance, if I gave you the original function is 6x squared, its antiderivative would be 2x cubed. What would you need to start with to have this as a derivative? That's what the antiderivative is. Would you agree that if you differentiate that, you get this guy? How about (10x to the 4)? Well, 2x to the 5 would be its antiderivative. How about 3x cubed? 3/4 x to the 4 would be its thing. I'm running short, you guys here. 7x. Its antiderivative would be 7/2 x squared. The antiderivative of 7x is this. It's the function, if you differentiated it, would get you back to that one. It's the undo of differentiation, right? And the notation that we use is the original question will be called f of x, and the antiderivative is going to be called capital F of x. Can anybody see a pattern of how you can take the question and find its antiderivative? Do you see any pattern in those answers? Because that's what we're going to use to do our first set of antiderivatives, polynomials.
You increase the exponent by 1, and then you divide, I don't know what you would call it, the number in front of x, the number that x is being multiplied by,
right,
by the x.
Yes, what Corbin said is correct. I phrase it, and you'll hear me say this a lot today. This is me just paraphrasing what Corbin said. Add 1 to the power and then divide by the new power. Okay, let's see what that looks like. 6x squared. Add 1 to the power, you get x cubed. Divide by 3, you get 2. Add 1 to the power, you get 5. Divide by 5, you get 2. Add 1 to the power, you get 4. Divide by 4, you get 3/4. Add 1 to the power, you get 2. Divide by the new power, you get 7/2. You see that that rule works. In general then, if you are doing ax to the power of n, right? 7x cubed, 10x, 50x to the 9th, whatever you like. You add 1 to the power and you divide by the new power. So that's the rule in English. That's how you find the antiderivative of any polynomial, any power of x. And this is what the rule looks like if you do it more algebraically, right? You see I'm adding 1 to the power and then I'm dividing by that new power. if you can memorize this rule, you can find the antiderivative of every polynomial in the universe, because they all follow that same rule. This is actually given a name, this rule. It's called the Thur rule for integration. Now, you might have thought it should have been called the Thur rule for finding antiderivatives. And it could have been called that, because it is. But you'll find when you do Calc 2 that we don't use the term antiderivative very long. It turns into the word integration. It's just another name for the same process, but it's a little bit more useful and it's easier to say. So let's put it into action. Suppose I give you a polynomial like 8x cubed, take away 2x squared plus 5x plus 1. And I almost forgot something. These answers are only 99% correct. And you might say, well, what's missing? I'll back to that question in a minute. Let's take, for instance, this fella, right? Now, if I want to check that that works, shouldn't its derivative, and differentiating is, shouldn't its derivative be that guy? And yeah, it is. It works. But what happens if you differentiate that guy? Don't you also get this? What happens if you differentiate this guy? Don't you still get this? What happens if I differentiate that guy? You still get this. Doesn't that mean then that the antiderivative function is 2x cubed plus some number, and it could be any number at all? Wouldn't all of them work? And so what we do is you add a c. And that plus c represents the unknown number that you could also have as part of your answer. Because wouldn't 2x cubed plus 4 work and 2x cubed plus 44 work? And so that plus c is essentially representing the unknown constant term. It even has a name. The plus c is called the arbitrary constant. And everybody has an arbitrary constant. So almost forgot that.
Someone said in chat there's a student trying to get into the call.
Thank you. I'll check it out. There you go. We're good. It's working. He said. Okay, right. Back to this question. I want to find the antiderivative of this. So add 1 to the power and divide by the new power. Add 1 to the power and divide by the new power. Add 1 to the power and divide by the new power. What do you think the antiderivative of the number 1 is?
It's x.
It's just x, 1x. And isn't plus 5 plus 5x and minus 2, its antiderivative was minus 2x. And don't forget, it's plus c. Now, WebAssign, when you put answers in, for some weird reason, and it is a totally weird reason, they stick the c at the front, it seems, and then they do that. Ignore them. Just stick it at the end and you're fine. It's just if you get the thing wrong and you see the answer, you'll see the C at the front and you'll think, oh, is that important? No, it's not. I guess it was the way it was programmed. Now let's try another one. Add 1 to the power, divide by the new power. Add 1 to the power, divide the new power. Would you agree that finding antiderivatives of polynomials, now that you've got this thing called the power rule for integration, would you agree it's quite a simple rule, isn't it? Add 1 to the power and divide by the new power. How about finding the antiderivative of this guy? What do you think I'm going to do to find the antiderivative of a function that's written in that format? What do you think I should do?
Thomas said expand it.
I would do that. Can you just trust me that it ends up being that guy? Now, that makes our job so much easier. Add 1 to the power, divide by the new power. Add 1 to the power. Do a 9x. Finish what I see. Okay. I'm having a technical issue here. I've lost you. Can you see me, guys?
Yes.
Right. So where the heck are you? Let me just pause for a minute and go hunting for you, because I like to see because it gives me an idea of what the heck I'm doing or not doing. There you are. What are you doing there? The video thumbnails are minimized to optimize something. Okay, evidently Zoom's just being awkward, but let's just keep moving. We've just finished. Wait a minute. Get an idea. It's helpful for me to see you guys, because then I can get visual clues to what the heck is happening.